This is section 1.2 on page 11 in our book. That's where the section begins. And on page 19, that's where the problems are. I'd like to look at some problems. The actual directions on numbers 2 through 20, it doesn't say graph, it says match. At least 2 through 6. But I'm going to graph them anyways. The prime, I want to just explain how this works. The prime right there, I changed some of the numbers, for copyright issues and stuff. So I match number 16 in number 6 in direction, for example. I match number 2 in direction. I match number 8 in direction. I just alter a few numbers, so the problem is not the same, but it's the same idea. And that's how I'm going to be lecturing all throughout the course. So I am going to go over what's needed for the class, not from an algebra point of view, from a business point of view. So whatever we cover, you really need to know. Whatever's not needed heavily, but it's there, I will point that out. So number 2 is a must. You must be able to graph straight lines. So the deal is 1.2 starts with graphing generally, and then 1, 3, 1, 4, and you move on, they start going more specific. For example, 1.3 talks about equations of lines specifically. Here they say graph, but in 1.3 they're going to really dissect that fully, and you're going to do a lot more than what we're going to do right here. But since this is how the sections are introduced, we're going to follow the trend. If I want to sketch a graph, you have multiple options of doing that. The best way to graph a line, if it's in y-intercept form or slope-intercept form, y on one side, everything else on the other side, is for you to start on the y-intercept, which is -2. And to notice the slope is the quantity in front of the x. So the slope of this line is 1/2. Again, in 1.3, we're going to talk about that. And I am going to start talking about what does the intercept mean and what does the slope mean. Again, for now, we're just graphing using algebra, but we're going to start looking at this from a business point of view, or with a business lens, if you would like to call it that. So I'm going to rise 1 unit up and 2 to the right, and get a straight edge. This book doesn't use arrows, but these lines are infinite. This line resembles all the solutions for this equation. Number 6 is not that heavy, you really don't have to be alarmed as much. I want to graph it because the graph comes up, but it's going to be provided, and not all of it, a portion of it. So like I said, I'm going to treat this class as a business class, not as a math class. I'm going to go over the minimum. Here they say match, that's why I'm doing this problem. So you look at x cubed, the intercepts. The intercepts are key for us. X equal 1, x equal -1. Since this behaves like a cubic looks like this. And the multiplicity on these zeros is a 1, which means this looks like a straight path among the zeros, like a straight line. And there's the graph, something like this. Again, you're matching number 2 and 6, but number 8 and 20, it says sketch a graph. If I want to sketch a graph of number 8, well, I am going to start at 1. Let's say that's 1 right there. The slope, the quantity in front of the x, is really -3/1. You must know what that means. Again, if there's no number in the denominator of any fraction, including a 0, you could assume there's a 1 there. This means for every 3 units that you rise, well, since it's negative, you're going to run 1, 2, 3. You're going to run to the right 1 unit. Or you could say this is 3/-1. For every 3 units that you rise, because it's positive, you would run back a unit. And if you fit those in a line, guess what? They all line up, or they should if you use the right scale. My scale is slightly off. Now, 1/x is a graph that looks like this. This graph is going to shift it 2 units to the right. 1, 2. Again, the shape of the graph, not the actual graphing part. If I put 0 in there, I'll get negative 1/2. Intercepts are key, and I'll talk about what that means, probably starting in this section. And intersection of lines, what that means. On the next set of problems, you'll notice it's asking for the intercepts. Find the x and the y intercept. So pretty much you're trying to figure out where does the graph cross the x-axis and where does the graph cross the y-axis. Well, if I have a line, let's say one of these lines, if it crosses the y-axis, I'm not sure what the y value is, but I know x value is 0 for sure. I know y is positive. And if I want to know where the graph crosses the x-axis, I'm not sure what that point is on the x-axis, but I am certain that the y is 0. So, to find the x-intercept, you would always set y equal to 0. And to find the y-intercept, you would always set x equal to 0. And that's a must. This is like you figuring out the cost of whatever product you have before you even make any of it. Right? Or how much you need to sell so that you could just break even. You know, all of these questions are going to come up. Intercepts are a must. So if I look at a problem like this, if this is an equation for demand or supply or cost, I'm always interested in the equilibriums, which are zeros. That is, how much would be the cost that is fixed, that doesn't depend on units? Well, to find the x-intercept, I would have to use algebra. I would have to set y equal to 0. So I take this equation, I'll say 6x minus 2 times 0 minus 8 equals 0, and I solve that equation, and there it is. So the algebra is there. And this reduces to 4 over 3. And you could use a calculator on any of these problems. So when x is 1 and 1/3, y is 0. And to find the y-intercept, I'm going to set x equal to 0. So 6 times 0, again, right there, minus 2y equal negative, minus 8 equals 0. Minus 2y equals an 8, and y equals a negative 4. And, you know, if they say graph, I could plot those on a number line and just go from there. That's all they wanted. Same deal here. Again, we're going to deal with nonlinear equations. The same deal though. All what I have to do is figure out the x and the y-intercept. If I want to figure out the x-intercept, I would set y equal to 0. So, take this equation right here, throw a 0 right there and a 0 right there. That will be 0 minus x squared equal 1. That means x squared equals negative 1. That's impossible. No solution, which means no x-intercept. What that means, this graph does not cross the x-axis. I could show you a quick example. Right there. That graph will never cross the x-axis. The graph of y equal 1 over x will never cross the x-axis. There are a few of those. So this doesn't exist. This graph does not cross the x-axis. Of course, we're not asking you to graph this. If I want to find the y-intercept, I could write better than that. I would set x equal to 0. So a 0 right there and a 0 right there will leave me with 0 minus 4y minus 0 equal 1. Or I could simply just write negative 4y equal 1, or y equals negative 1/4. So that y-intercept is, when x is 0, y is negative 1/4. Another topic I want to barely touch on, hopefully reminding you of it, is a circle. A standard equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center is always the opposite of what's in that square stuck with x and the opposite of what's stuck with y, and the radius is actually the square root of that number. And I want to do two examples on this really quick. Again, we'll come back to this and we will apply this heavily. So directions, find the standard form of the equation of a circle with the given characteristics, and let me get that copied up. And here we are, a couple of problems. Again, very close to number 34, very close to number 36. Well, here it's really x minus whatever that is, y minus whatever that is, equal whatever the radius is squared, or simply x squared plus y squared equals a 9. Now, if I wanted to sketch the graph of this, it's a lot simpler than you think. I know students think graphing is hard. Actually, graphing is really simple. All what you have to do is start at the center and move this radius 1, 2, 3 in all directions, left and right, up and down. Fit that with a circle, and guess what? Again, if the scale is off, that would look like a perfect circle. There it is. And if I was to look at this equation, that is x minus, it's always minus that, so it's x plus 3 squared plus y minus 4 squared equals 2 squared, right? And if I wanted to sketch a graph of this again, graphing is the easiest part of math. I know students disagree most of the time, but you'll be surprised how many people convert. Switch 1, 2, 3 to the left, 4 up, move 2 units in all directions. So 1, 2, 1, 2, 1, 2, and 1, 2. And if I fit those, there's that circle. And that's pretty much what we have as far as graphing or matching. Having a graphing utility is very good, but you should really practice doing those by hand. Not because we want you to learn those mathematically, because we need you to understand what they mean in business. And if you graph them by hand, you're in a much better shape. Okay, the last problems I want to do for this lecture, not the section. I haven't talked about business yet. I'm going to get the algebra out of the way, and the second half of this section, I'm going to really start emphasizing the business application of this. Find the points of intersection, if any, of the graphs of the equation, and again, I'm going to explain what that means later on. If I'm given two equations, you know, this could be supply, one could be demand, one could be revenue, one could be cost. So if I use the substitution, that is, if I take this y and replace it by what it equals right there, I will be looking at 2/3 x minus 4 equals a negative x plus 5. And here's where math is very handy. If I find the LCD, which is 3, and clear, multiply all of these by 3, that will be 2x minus 13 equal negative 3x minus 12. I'm horrible with math. You guys gotta help out. And 5x equals 27. x would be 27 divided by 5. And once I find x, I could find y. I could say y is negative 27 over 5 plus 5. Again, the LCD is at 5. Multiply everything by 5. This adds an extra step to the problem, but I think it makes life a lot easier. You know what? I messed up really quick. I apologize. I got excited. That does happen a lot. If I take x to be... Oh yeah, no, it was right. Oh man, what have I done? It was perfect. I messed up. Okay, there we go. Perfect. Yeah, I used this equation. So 5y would be at negative 2 and y would be negative 2/5. So here we're just using algebra to figure out what the intercepts are. We're not saying what they mean. We're just using mathematical interpretation, or we're just finding mathematically. We're going to talk about what that means in the next part of this lesson. So I'm breaking this section into 2 lessons. The same deal here. This is what y equals. This is what y equals. So I could replace either here, put it there, or the other way around. I could say instead of this y, I'm going to use 2x plus 2 equals x squared minus 1. To solve a quadratic, I get 0 on one side, everything else on the other side. I would factor. X would be a 3 and a negative 1. If x equal a 3, I'll use either one, it doesn't matter. Let's say that one. 3 squared is 9, minus 1 is 8. And if I use x equal negative 1, negative 1 squared is 1, minus 1 is 0. Those would be the intercepts. And there's your homework. Section 2.1 on page 19, number 1, 5, 7, 19, 23, 31, 33, 35, 41, and 45.